So let's do an example of calculating a confidence interval, and then when we're done with the calculations, we'll talk about what this confidence interval means. So suppose that 383 out of 735 surveyed voters support a particular political candidate. So we would like to know the proportion of all voters that support this particular candidate. Using this information, we can get an estimate of that population proportion, but we want to get a measure of its accuracy. So specifically, we want to calculate a 95% confidence interval estimate for the proportion of all voters who support the candidate. And so we're going to do this in a series of 5 steps. The first is to define the population proportion being estimated. And when we define this proportion, we don't simply restate the question or restate the problem. We define what it is we're trying to estimate. In this case, we're trying to estimate the proportion of all voters who support the candidate. And we're going to denote that by lowercase p. Now we stress the word all here because we're interested in the population of all voters, not just the 735 in this sample. Next, we're going to calculate the sample proportion. And so in this case, asking these 735 people, that's a series of 735 Bernoulli trials. And a success here is getting someone who supports the candidate. So we have 383 successes. So we'll take that number of successes divided by the number of trials, and we get 0.521. That's our sample proportion. So based off of this, it looks like about 52% of the voters support this particular candidate. The third step is to find the critical value. Now, to find the critical value, we first need to identify the significance level. That's denoted alpha. Now, what we're given in the problem is to use a 95% confidence level. Remember, the confidence level is just 100 times 1 minus alpha. And so if the confidence level is 95%, that means alpha is 0.05. So then our critical value is z sub alpha divided by 2, which is z sub 0.05 divided by 2, which is z sub 0.025. So we look at that table of critical z values, and we get our critical value of 1.96. So no calculations need to be done there, assuming that we're using a common value of alpha. Okay. Fourth step is to calculate the margin of error. So here's our formula for the margin of error, and we just plug things in. Here's the critical value, p hat, 1 minus p hat divided by n. We do that arithmetic, and we cut 0.0361. Now from there we calculate the confidence interval. And so here's the form of the confidence interval that we're going to use. The lower limit is p hat minus e. The upper limit is p hat plus e. And so now we just plug in our numbers. Here's p hat minus e, p hat plus e. We do that arithmetic, and here's our confidence interval. 0.485 is less than p, is less than 0.557. Now, let's talk about what these different quantities mean. The margin of error is 0.0361. So we would interpret that by saying we are 95% confident that the maximum distance between the estimate of 0.521 and the actual value of p is no more than 0.0361. So this gives us an upper bound on that error, or that maximum distance between the estimate and the actual value of p, okay, at the 95% confidence level. Now here in a minute we'll talk about what that confidence level means. Now our confidence interval, p is somewhere between 0.485 and 0.557. We would interpret that by saying we are 95% confident that the actual value of p is somewhere between these two numbers, 0.485 and 0.557. Now, what's significant about that confidence interval is that the lower limit is less than 0.5. So what that means is that the true value of p could very well be less than 0.5. It could be as low as 0.985 at this 95% confidence level. Now, on the other hand, it could be as high as 0.557 at the 95% confidence level. And so the fact that this lower limit is less than 0.5 means that this candidate isn't necessarily winning. He or she may have less than 50% support. Now, one question we might ask is, what does that confidence level of 95% mean? Well, let's give a correct meaning, and then we'll give an incorrect meaning and talk about the difference between them. So the correct meaning is that if we were to survey many different samples of voters and calculate the corresponding 95% confidence intervals using the statistics from each sample, then about 95% of the intervals would contain the true value of P. So it's saying that if we did this process of going out collecting data and calculating the confidence interval many, many times, then about 95% of our confidence intervals are going to contain the true value of P. Now, an incorrect meaning would be to say that there is a 95% chance that the actual value of P is somewhere between those two numbers. So why is this an incorrect meaning? Well, let's make a couple of observations. Number one, P, the population proportion, is a number. I don't know the value of that number. Nobody does, but it is a number. It has a single value. Okay? So that number is either between 0.485 and 0.557, or it's not. It's either there or it's not. There's only two possibilities. So there's no probability involved. P is either there or it's not. So there's no probability or chance involved there. It's either there or it's not. We don't know which, but there's no probability involved. So what this illustrates is that the confidence level refers to the process of constructing the intervals, not the intervals themselves. Once the interval is constructed, P is either in there or it's not. There's no probability or chance involved there. It's already been determined. Now, we don't know what that determination is, but it's already done. So again, the process of constructing the intervals means that, again, if we were to construct many different intervals, then at the 95% confidence level, about 95% of those intervals would contain the actual value of P. That's what the confidence level means. If we were to work at a 99% confidence level, well, then about 99% of our confidence intervals would contain the true value of P. If we worked at an 80% level, then about 80% of them would contain the true value of P. So last thing we need to mention here are the requirements for using this definition of the margin of error and the confidence interval. As we've pointed out many times before, you can't blindly plug any set of numbers into any formula and expect to get valid results. They're only valid if certain requirements are met. So in this case, we have three requirements. Number one, the sample must be random. That's always a requirement for using any sort of statistical tool. We need our sample to be random. Number two, the conditions for a binomial distribution must be satisfied. Remember, binomial distribution, you've got a set of n trials. They're independent. Each one is a success or failure, and the probability of success doesn't change. So as long as those requirements are approximately met, then this second requirement is satisfied. And then the third is that there are at least 5 successes and at least 5 failures in the n trials. And this third requirement is necessary to ensure that the sample proportion has an approximately normal distribution.